All right, let's jump right in. Today, we're talking about a new kind of AI. It doesn't just make virtual people. It makes virtual people that feel like they're actually present with you, in the same room. The whole system is called Sarah. And honestly, it's a huge step toward a much more believable digital future.
But first, let me ask you something. Have you ever been in a VR chat or played a game and just felt that something about the characters was, I don't know, a little bit weird? They're talking, they're moving, but there's this weird glassy-eyed disconnect. If you've felt that, you're definitely not alone.
In this picture, this gets right to the heart of that weird feeling. You see, most current AI agents, they're programmed to react to your words. But as you can see here, if you move around, they just kind of stare into the middle distance. It completely shatters the illusion. It's like they have no idea you even exist in the same space as them.
And yeah, there's actually a name for this whole thing. The uncanny avatar problem. The thing that's missing, the secret sauce, is what's called spatial awareness. It's that basic ability to know you're there, to track your movement, and to react, like a real person would.
Okay, so that's the problem. What's the solution? Well, it's this huge breakthrough at the core of this research, a whole new kind of AI that is, you guessed it, spatially aware.
And this diagram, it really lays out the whole idea perfectly. The goal is no longer just making an avatar that can talk at you. The real goal here is to take in all this information about you, where you are in the room, what you're saying, and use it to generate a 3D avatar that responds to everything. It's not a one-way street anymore. It's a real, dynamic conversation.
And the system that pulls all this off is called SARA. It stands for Spatially Aware Real-Time Agentic Humans. It's a bit of a mouthful, I know, but trust me, every single one of those words is important, as you're about to see.
So what's the big deal with Sarah? Well, it's the very first system that manages to juggle 4 massive things all at the same time. 1, its gestures actually match what it's saying. 2, it's spatially aware. It follows you with its head and body. 3, you can actually control its gaze, which is huge. And the real kicker? It does all of this in real time, fast enough to run smoothly inside a VR headset.
All right, let's pop the hood and see what makes this thing tick, shall we? Don't worry, we won't get too bogged down in the super technical stuff.
So from a bird's eye view, the whole system works like a pipeline. On one end, you've got stuff coming in, your location, your voice, the agent's own voice. All that data gets fed into this smart generative model, and on the other end, it spits out this super fluid, responsive 3D motion for the avatar.
Now that engine, that generative model, really has 2 main parts. First, there's something called a causal VAE. You can just think of it like a super smart zip file for human motion. It takes all that complex motion and compresses it down into just the essential bits. Then you have the flow matching model, which is kind of like the artist. It takes that compressed data, adds in your live position and audio, and paints a brand new, totally appropriate motion from scratch.
And check this out. This is one of the really clever tricks they used. Instead of representing the avatar skeleton with old-school joint angles, which can get a little clunky, Sarah treats each joint like a 3D shape, an icosahedron to be exact. It sounds complicated, but what it really means is the whole system is way more stable and has much more precise control. It's a little change that has a massive impact on the final quality.
Okay, let's switch gears and talk about something that's maybe one of the most powerful parts of any human interaction, right? Eye contact.
So the paper points out something that honestly we all just know. How much eye contact feels right is totally different for everyone. It depends on your personality, your culture, the situation you're in. If you try to make a one-size-fits-all rule for eye contact, it just feels, well, creepy. So for an AI to feel real, its gaze has to be adjustable.
So how in the world do you teach an AI to handle something so subtle? Well, you go to the source. You study how actual people do it. On the left, you're seeing a real human conversation from the data they trained the AI on. And on the right, that's the geometric model Sarah uses to basically understand and copy that behavior. It just looks at the direction the agent is facing versus the direction to the user. And all that math spits out this really neat metric they call a gaze score. It's just a number from -1 to 1. 1 means they're looking right at you, -1 means they're looking completely away. But here's the brilliant part. You can actually tune that score in real time to get the exact level of eye contact that feels comfortable for you.
Okay, so we've got motion that's aware of you, we've got a gaze you can control, but the last piece of this puzzle, honestly, it might be the most mind-blowing part, the speed. Making it all happen instantly.
See, here's the problem with a lot of the older models. They had this one huge flaw for live stuff. They were non-causal. That basically means they had to peek a few frames into the future to figure out what to do now, which is fine for making a movie, maybe, but in a live chat, it creates this awkward, impossible lack.
But Sarah, it's completely causal. And that is a game changer. It means the AI doesn't need to see the future. It just reacts to what has happened and what is happening right this second. And that allows it to respond to you instantly, with no delay you can possibly perceive.
And when I say instantly, how fast are we talking? We're talking over 300 frames per second. I mean, to put that in perspective, your fancy VR headset is probably aiming for 90, maybe 120 FPS to feel smooth and avoid motion sickness. 300 is just incredibly, incredibly fast. And this table here just makes it crystal clear. Look at the old methods, the baselines. Not only are they 3 times slower, but remember that non-causal problem? Yep, they're basically unusable for live interaction. Sarah isn't just a little better, it's playing a whole different ballgame.
So let's bring it all back home. Why should you care about any of this? Well, this is the kind of tech that leads to virtual meetings where you actually feel like you're in the room with people. It's what will make digital assistants feel less like a robot and more like a helpful partner. Really, what we're looking at is a brand new chapter in how we interact with computers, one that feels a lot more, well, human.
And that kind of leaves us with one last big question to chew on. For so long, we've had to learn their language, right? Clicks, taps, commands. But what happens when our digital selves, our AIs, become this lifelike, this aware? When they start to become this, well, this human, how does that change everything? It's a pretty wild thing to think about.